doesn't know whether it's going in a vector or a scalar. It just wants to attack the food. It wants to attack its prey. This is physics.
Today we're going to show you the difference between a vector and a scalar. And this demonstration is the scalar. Ready?
Go.
Set, go.
Turn it.
Napoleon just traveled a distance of 3 meters. In physics, this value is called a scalar. It tells us the magnitude that he has traveled. However, it does not specify in which direction he went. That value would be called something else. So let's find out more from Professor Nicholas.
Well, hello there. I didn't see you. A value that gives both a magnitude and direction is called a vector. Distance only gives you a value of magnitude, from which one is traveled. However, displacement is a vector, and thus gives both magnitude and direction.
Napoleon's displacement would be 3 meters to the left.
Now say you want to find out how fast Napoleon is going. You might call this his speed. Well, that is only a scalar. In physics, we use a more educated word, velocity, which is a vector.
In order to find velocity, you must know both distance and time. The equation for velocity is average velocity equals change in distance over the change in time. So say that Napoleon traveled 3 meters in 2.5 seconds. His average velocity would be 1.2 meters per second to the left. On a v versus t graph, velocity would be constant in a straight line where 1.2 meters per second is as time increases. Another value in physics to consider when finding velocity is acceleration. Acceleration is the measure of velocity per a unit of time. When an object is falling on Earth, its acceleration is due to gravity. The value for gravity is negative 9.8 meters per second squared. Therefore, when something is dropped or thrown up in the air on Earth, the value for acceleration is negative 9.8 meters per second.
On Earth, when an object is falling, acceleration has the same effect on it as it would for any other object. The mass or size of the object does not have anything to do with the acceleration. Acceleration will always have the same effect on an object, and it will be at negative 9.8 meters per second squared. This is due to gravity, and this is excluding wind resistance.
We will now do a demonstration to show the effects of acceleration on all objects. We will be dropping a 10-pound weight in an apple. Which do you think will hit the ground first? The apple or the 10-pound weight, or will they hit at the same time?
We have an apple and a 10-pound weight. And we'll show you which one will fall first due to acceleration.
After that demonstration, we can tell that both an apple, which is very light, and a 10-pound weight, which is a lot heavier, landed on the ground at the same time. This shows that acceleration affects all objects the same way. Is that good?
Yeah!
So now let's review some of the physics that we just learned. First, we talked about scalars and vectors. A scalar is a value that just provides you with a magnitude. An example of this would be distance. A vector is magnitude and direction. An example of this would be displacement and velocity. Speaking of velocity, we learned that the equation would be distance over time. Next, we talked about acceleration. An acceleration due to gravity gives you a value of negative 9.8 meters per second squared. On planet Earth, this negative 9.8 meters per second squared will cause the acceleration of something as light as an apple and as heavy as a 10-pound weight to land on the ground at the same exact time.
So I hope you all enjoyed this video and learned something as well. That's physics!